please post the question and in the chat box, and we will deliver it to the presenter at the end of all presentations. Now I will give the floor to my colleague, Professor Samuel, in order to handle the session, and I will be with you at the end in the question and answer session.
Thank you, Professor Kal Jabri. Thank you very much for your kind words. It's a pleasure and an honor to be here with you. Also, thank you to all the audience and the panelists for attending this very interesting session. From Spain, that we were talking with the professor, we are facing very similar issues and dangers than all of you. We are with a good will to learn from all of you the solution approaches and strategies to try to improve our world. So let me introduce Sneha Asrani, that is going to talk us about the thermally comfortable, affordable housing. It's a very common problem that we are in our society. We are confronting, and we are going to learn about a study on residential building code in India. It will be very interesting for all of us. Please, Sena, you have the control of the presentation.
Hi, my name is Sneha Asrani, and I'm from India. Can I share my screen?
Yes, you are now. You have the possibility. You have to press the button that is. They have an arrow. Okay. We can see you. We can see your presentation.
Yeah. Okay. So we did this study on affordable housing and how we can make it thermally comfortable following residential energy building codes in India. So because we have such a large population and rapid urbanization, we would need to add 20 billion meter square of new building floor area, which essentially means that 70% of the buildings that India needs, they are being constructed right now in this very decade. So to bridge this housing shortage gap, a mission called Housing for All by 2022 was launched. Under this mission, we have a scheme called Pradhan Mantri Awas Yojana, under which affordable housing is provided to the economically weaker sections of the society. So it was decided that close to 20 million houses would be provided, which has now come down to 11.4 million houses, out of which 5.1 million houses have already been constructed. People are living there. And overall, India has invested more than 14 billion US dollars in the scheme. But what is parallelly happening is that climate crisis is worsening. India is anyway a tropical country, and the average cooling degree days in India is 3,000. And metropolitan cities face the brunt of this. So to make themselves comfortable, not that the summers are getting intense, the winters are getting intense, to make themselves comfortable, the occupants would need to take help of mechanical equipment. But not everyone can afford it, especially the occupants of these affordable houses. They might not be able to afford an AC. But that does not mean that they do not need to be comfortable. Housing should serve the purpose of shelter as well as provide comfort to the occupant. So the solution to this is building energy efficient buildings, reducing the cooling load. And that can easily be done if we make a tighter building envelope. So in 2018, the Bureau of Energy Efficiency in India launched a residential energy conservation board code, which we call as Eco Niwas Samhita. This code put forward a metric called the RETV, Residential Envelope Transmittance Value. It's basically a measure of how the building's envelope performs thermally, how much heat permeates into the building. So we combine the buildings, we are trying to look at the buildings being constructed under PMAY scheme through the lens of RETV. India is divided into 5 different climatic zones as per our National Building Code, which is hot and dry, warm and humid, composite, temperate, and cold climate zones. So to get the data, we accessed government websites, municipal corporation websites that provided information about PMAY projects being constructed in respective cities, in respective climate zones. So we gathered information regarding what climate zone they were being built in, what is the construction status, and if their technical drawings, if the building technical drawings are available, and what is the walling assembly. So we got a list of 80 projects. From that, we further filtered these 80 projects based on if the building technical drawings are available. Finally, we came down to a list of 30 projects in which all the data that I mentioned before, like the technical drawings, walling assembly, climate zone, and construction status, all information we could get. And this also meant that all these 30 projects, they were from different climate zones from India and had various walling materials. These projects had at least one building, meaning that one project could have more than, say, 4 buildings at once. So the RETV of each building of all projects was calculated. So as I said before, that we gathered a total of 30 projects, and the RETV of 92 buildings from these projects were calculated. So how do we calculate RETV? What does Eco Niwas Samhita give us? First of all, the input parameters of this tool. The foremost thing that we need to enter into this tool is the latitude, because that would tell us how much, that would tell us something about the sun. Then we need to enter the wall surface area, the walling material, walling material, and the orientation of each wall. Then we also enter details of window, door, and ventilator, which means what is their size, are they openable, how much of their area is opaque, how much is transparent. The last details that we enter is of roof assembly. That means what is the roofing material. The ENS compliance tool gives us RETV, WFR, visible light transmittance, and U-roof as output parameters. RETV is basically the building envelope's thermal performance. WFR, window to floor ratio, is the ratio of total window area to the floor area. This is important when we need to maintain the natural ventilation within the house. And yeah, visible light transmittance. It has to do with the natural light, the visual comfort. And Q roof. It's the thermal transmittance value of the roofing material. For different climate zones, ENS has set minimum or maximum compliance values. So for RETV, for all climate zones except cold, the maximum RETV is 15. Moving ahead, first of all, we calculated the RETV of all projects. I would like to start with the chart or graph B in this slide. We have RETV on the y-axis, orientation on the x-axis. The mean RETV for east-west orientation is found to be the least when compared to other orientations. We'll come back to this later. Now we'll start with graph A. So for different climate zones, what is the range of RETV? For hot and dry climate zone, 55% of the buildings were found to have non-compliant RETV, and for composite climate zone, similar amount of buildings were non-compliant. Now, to understand why that happens, we will have to look at what walling materials are preferred in these climate zones or regions. So looking at the hot and dry and composite climate zone bars, in both of these climate zones, AAC blocks, which is autoclaved aerated concrete blocks, normal burnt clay bricks, and fly ash bricks. These materials are common across both these climate zones. Again, what causes so many buildings to have non-compliant RETV values is the use of precast wall and slab walling material and monolithic RCC. Both of these materials are concrete based. Similarly, now we look at warm and humid and temperate climate zones. Here, almost all buildings are found to be compliant. So, in warm and humid climate zone, this also has AAC blocks, bricks, and this precast wall and slab as well. These are the 2 or 3 outlier dots that we can see in graph A. The interesting thing here is that in temperate climate zone, the walling materials used were solid concrete block and monolithic RCC, but still the RETV was much lower. Like the RETV values were compliant, and that was because the buildings had a lower walling surface area, which means that they were low-rise buildings, 2 or 3 floors tall. To look at, so in this slide, we drew a relationship between what the walling material is and how the RETV is getting impacted. But what parameter of the walling material decides or impacts RETV, we find out in the next slide. So here on the primary x-axis, we have RETV. On the primary y-axis, we have thermal transmittance value, U value, which is the inherent property of a building block or walling material to transmit heat. What is happening? So the reason I have highlighted these 3 materials, AAC blocks, burnt clay bricks, and fly ash bricks, is because they are conventionally used, like wide used in our industry. So the AAC blocks have very low U value. Concurrently, they produce envelopes with lower RETV value. while burnt clay bricks and fly ash bricks, they both have relatively higher U values, and thus the RETV is also higher.
Neha, you have 2 minutes left.
These two materials highlighted in blue, one thing common between them is that they have EPS score. What this means is that they have some kind of an insulation to them. Insulation would basically not let heat to transmit, and thus the envelope would be cooler. That reflects in their U value as well as their the RETV of the buildings. And next we have these three materials: monolithic RCC, precast wall and slab, and structural stay-in-place formwork system. All three systems are concrete based. These systems are preferred because their speed of construction is so we can optimize the speed of construction. We can build in lesser days. But what about the thermal performance of these materials? The graph clearly shows that all three materials have relatively quite higher U values. And thus the RETV of the buildings in which they are used is higher. So what use is, building faster if you cannot have a comfortable house in the end?
Neha, we need to summarize.
Earlier,
we need
how
to summarize
we
last minute.
Parallels between U value and RETV. To confirm that, we regressed RETV and U value, and we got a strong correlation, which means that at the minutest level, the thermal performance of a single individual block would impact that of the thermal performance of the building. And this graph B, which we talked about earlier, about the orientations in RETV. So the RETV for east-west orientation is found to be the lowest and by far compliant. What this means is that if we have a building, the best orientation for it would be east-west, which would make it perform better in terms of heat transfer. This does not mean that you can take any two different kind of buildings in any different kind of climates, and when you compare one with the other, and if one of them is in east-west orientation, the other in some north-south, then the east-west one would do better. It just means that if you have one building in different orientations, the east-west orientation would do better any day. The other parameters of the ENS compliance tool are window to floor ratio and U-roof. The WFR was found to be compliant for most of the projects, while the U-roof was not. This points out to the most important finding that we invest so much in building better envelopes, but we somehow forget about the roof.
Neha, we need to finish the presentation. Please, a sentence to summarize.
I'm sorry, are you saying something, Professor?
We need to finish the presentation, so please, a sentence to summarize your paper.
Professor, you are muted. I cannot hear you in case you're trying to say something.
Do you hear me?
Yes, you need to conclude your presentation. The time is over.
Since Sina has some problems with the audio, so we need to finish the presentation now and go to the next panelist. We can discuss further in the question sessions. So thank you very much for your presentation. Very interesting indeed. but we have to adjust to the time schedule. So I'm going to recover the control. And I would like to welcome to Dana Alfana Al-Raimi from Oman, and she's going to talk us about also a very interesting topic and very related with the first we're discussing. It's through a local sustainability rating system for Oman. So we are moving from India to Oman, and also, but also we are discussing about how to develop some kind of regulation standard to evaluate and to enhance the sustainability. So thank you very much, and you can start in the moment you are ready.
Hi, can I start? I want to make sure that the screen is shared with you.
Yeah, we can see your presentation. So
oh, thank you.
You have the floor.
Good afternoon, and thank you for sharing the platform. I am Dana Arimi, and I'm going to present our work toward a local sustainability rating system in Oman. Starting from the point that Oman as a country didn't have a local rating system. And we know that the Omani government are aware of the side effects of construction. And it is clear that in Oman vision, the sustainable development lies at the heart of the vision. So there are a proactive action are taken by the government to encourage the development of sustainable construction practices, and the role of the built environment as a key component of the Oman Sustainable Development Agenda has been recently acknowledged by the government. And by that time, it will not be an option for the government to delay or postpone the establishing of a measurable criteria to force the implementation of sustainable buildings. However, the development in this area is very slow compared to other GCC countries. And most of the existing sustainable rating systems, which are used in these countries, are designed in terms of top-down approach. And this approach might project significant elements and might not be applicable for the stakeholders. So the approach in this research focuses on understanding sustainability from the stakeholder perspective, using social constructionism theory to highlight the essential component of sustainability, and to direct the decision maker in the future to the proper approach to customize a local rating system that consider the cultural and historical dimension of the country. Moving to the research aim and objective, the aim of this study to pave the way for development of local rating system in Oman based on Omani stakeholder groups' perception of sustainable built environment, cultural values, and inspiration. The main objective of this research can be summarized as follows. First, identify and map stakeholders in the field of construction. Second, to understand Omani stakeholder point of view of sustainable built environment, and to identify the sustainability components based on them. Third, to explore the difference among the stakeholder groups in terms of knowledge based on social demographic factors. Four, to summarize the similarity and differences between identified components in one hand and the structure of leading rating system on the other hand. In order to address the study objective, a mixed method approach was used, and several methods were adapted for the data collection and analysis. Therefore, the work in this study was divided into several interconnected tasks and activities. We can say the particular innovative dimension in this study is the use of rigorous combination of stakeholder groups, identification and mapping techniques, and the initiation and consensus development method. So, literature review and expert panel discussion and power interest matrix was used for identifying and mapping stakeholder groups. Then the free listing, silence index, file sorting was used to understand the Omani stakeholder understanding of sustainable built environment. Then the statistical analysis was used to explore the differences in knowledge among the groups. Finally, the literature review and the file sorting was used to summarize the similarity and differences. To identify the stakeholder groups, a workshop was conducted with the help of two experts, and the initial list of the group was presented for them. The initial group was consists of 7 groups, which are the government sector, educational, design, professional groups, investors, contractors, and specialists in sustainability. After a deep discussion and having a brainstorming session, more 2 groups were added, which are end users and end user operated rated buildings. And in each group, the target institution was listed, as shown in the table. This slide shows the process of stakeholder mapping, and this process came after listing the target groups and after having the name or the list of the institution in each group. And the mapping was based on power interest matrix. Based on stakeholders' power and interest, using the power interest matrix, we have 4 groups. And these groups are categorized based on their power to make a change and their interest in sustainability. So we have 4 groups, which are the crowd that have a low power and a low interest, the subjects who have a low power with a high interest, and the context setter, high power with the low interest, and the players who have the high power and the high interest. So in the table show the sectors based on their level of power and interest. For the crowd, we have in the crowd we have private local design consultancy, the end users, and the users operated buildings and contractors. And for the subjects, we have a professional group, education institution, Haya, which is a local company, and Athens is multinational company. And for the context sector, we have Ministry of Municipalities, institution, Ministry of Tourism, and Ministry of Housing, and the players, Muscat Municipality, PDO, and SAS, Ministry of Environment, and Supreme Council of Planning. Here we can see the final matrix of power basis interest with the 4 groups and the institution. This was generated in the workshop. To analyze the cultural domain, this research is based on the theory of social constructionism, which believes that knowledge is constructed through social interaction and shared. Also, what is defined by human and society is the reality. And the theory views the knowledge as a human product occurs when individuals are engaged in the social activities. Therefore, the theory assumes reality and knowledge as are gained from interaction with the society members and differ from society to other. And therefore, there are different methods for collecting lists and to show the similarity among the items. And in this research, we use the pre-listing plus the bias sorting in the interaction with the society to identify what we need in this research. In the pre-listing task, the question was for the participant, what makes a building sustainable? And they were asked to list whatever comes to their mind, even if they are thinking it is important or not, even if they are not expert in it. And we got a lot of terms to explain sustainability from their point of view. Here are the most silenced terms after filtering the data and after defining the core elements. We got 27 terms that define sustainability based on the stakeholders involved. Then we calculated the frequency, the main rank plus the silences index using this equation. After identifying the core elements of the study, the terms was listed from the highest to lowest, as it's shown in the plot, and we got 5 categories based on the value of the silence index, starting from the high to the medium high, medium low, and low. And this table shows the terms as it is grouped based on the silence index. The highest one, as it is shown, the green area with silence index 1.62, and the lowest terms are durable structure, future expansion, and etc., as it's shown in this table. After identifying the core elements of the study, a bias sorting workshop was conducted with involving representative of the stakeholder. The list of the terms was presented and the participant was involved to discuss and find the connection among these terms and check the possibility to group them. Based on the bias sorting workshop, we got 4 groups: the material construction, social requirement, efficient of design, and finally the cost optimization. In order to explore the similarity and the differences among the systems, we listed the terms and compared with the terms and the categories and indicator in lead and BREEAM. We can see there is some similarity and some differences. In the similarity, you can see the natural lighting, use of renewable energy, respect wind direction, orientation, and using friendly material. To summarize the results, the knowledge of stakeholders are affected by gender, level of education, stakeholder group, and engineering field. The female are more knowledgeable, PhD participants are more knowledgeable, and the knowledgeable groups are the professional groups. Moving to the limitation of the study, we can see the study was conducted during the pandemic, so there was a limited access to some of the stakeholders. Also, this study was target only the Omani society, so the outcome of this study will not be applicable to another society. And also, the study ranked the terms based on the science index value, not on the importance. Also, one of the limitations that we don't have a previous study that showed the level of knowledge in sustainability. And we have only one price sorting workshop. We need a clear and updated and accessible database maintained by government or authorized body. Also, this results and terms and categories generated from this study can be used by the government to establish a base structure. Also, to raise the awareness of sustainability in the media, also in the groups who have a high power and interest to change. Thank you very much, and it was a pleasure to present our study in this conference. Thank you very much.
Thank you very much, Dana, for your presentation and to fix to the time schedule. It's a very, very interesting presentation, and also some challenging questions are arising that we are going to discuss afterward. So please keep ready your questions for the final session. And now I would like to introduce to Hawar Al-Jabri, that's going to talk us about a very related topic. That is how can we link the emotional sensation appraisals about sustainability and about comfort control. I think it will be a very interesting presentation to end the session. So let me introduce Hawar Al-Jabri, and you have the floor for the presentation. We can see your screen, so go ahead the moment you're ready.
Hello, everybody. Did you hear me? The sound is okay for you?
Yeah, we have sound from you.
Okay. My name is Jawahar Salim Al-Hajri. I will talk about an empirical approach to explore the relationship between the architectural features and effective appraisals. It's a virtual reality study. Talking about the introduction of the study, it's a study the quantitative relations between the architectural spaces and applied some physical features in the study by using virtual reality simulation. The statement of the problem of this study, we know that using traditional methods of representing the architectural spaces, either it's 2D, either it's 2D or a 3D presentation. This will make the users more difficult to judge about the space. So it will be not enough to judge the space by using these traditional methods. And as well as it causes some time overrun, and cost of the project. Therefore, the aim of my the interaction between the human and built environment must be very effective. So make the users judge clearly about the space, whether they are interesting, relaxing, and pleasant about the space. And all this is depend about the effective appraisals of the space itself. The aim of the research is to find this relationship about the effective appraisals and physical features. And it comes also another sub objectives to achieve the original or the main aim of the research, which is the investigate the effective performance of the users about the indoor spaces. Also to assess at what extent these physical properties will affect the emotional state of the users about these spaces. Also to examine the virtual reality as a tool to make the framework or to make a platform for the architectural spaces, whether there is a relationship between these qualities or not. The main hypothesis of the empirical study is effective appraisals happen when a person or users judge judge the design attributes of the architectural spaces. And there are sub-objective, it's according to the main hypothesis, which is help to examine many simulation methods to measure these affective appraisals, which is simulator desktop walkthrough and immersive PC virtual reality, which are used in this study. Also to investigate the affective appraisals of the architectural indoor spaces, especially in Oman region, and measure how much the change of these physical properties of the architectural spaces will make a difference in the effective appraisal of the users. The methodology used in this study, consists of three phases. First is design phase, representation phase, and the final phase, which is the evaluation phase. The design phase it's a start from the designer. The design will generate some design options. These design options comes of some selective attributes, which is finished material or space height, and also it's effective. It's about selective appraisals, donative qualities, spaciousness, brightness, collative qualities, enclosure, complexity, and emotional qualities like pleasantness and excitement. After the designer will generate these design types, the design type will make some interaction between two attributes. So it will generate four designs: modern style high ceiling, modern style low ceiling, traditional style high ceiling, traditional style low ceiling. And after that, it's representation phase, starting from modeling the space and using a program like a Revit program, and using Inkscape plugin that will help to present the space in an effective way. It's by using immersive interface VR, which is by using a headset, or by using desktop walkthrough, which is through an online. After that, the final evaluation phase, which is the collaborative design assessment, so that the users will assess of two different groups by age and by professional. which is architect, non-architect, the most users that are focused in this study. And then simulated design experiment, a questionnaire, and finally there is the data analysis. So the data analysis, it's updated and going to construct a building, or it's going back to the design to choose another attributes or effective appraisals that will be related to each other. So from my methodology, the generating of the design option, it's selected two parameters, so it will be four alternatives and 6 scenarios. Why I select 2 parameters? Because as you see in this table, if I select more parameters, so it will be more scenarios and more time consuming on the study. So I limit my study to use 2 design parameters due to the time limits. So this graph is showing that generating virtual test spaces. So finally, it's generating 6 scenarios from 2 type of parameters. So this is the selected case study. It's a simple fish market, and I select only this this highlighted area, which is the main hall of the study. So the virtual reality users will use the users as a general will use this path to going through and test the space. This graph is showing that using the plugin in Revit program, and in this box, it's showing that exporting data for the online or desktop users. These are the four designs that is generated from the program. The participants used in this program, which is total of 50 participants, 45 participants, which is using the via email desktop walkthrough, and only 5 participants were using head-mounted display. This is due to some limitation about COVID-19. So it does not make me to make more participants are using this head-mounted display. So these are the users identification, which are architect 20 to 30 years old, non-architect 20 to 30 years old, architect 30 to 45 years old, non-architect 30 to 45 years old. The experiment procedure, which is the immersive interface, which is by 2 users, which is immersive interface VR and desktop users VR. I will go to fast. First is the first step. It's the preparation of the experiment, and then calibration and training how to use this head-mounted display. Finally, which is testing the experiment of the VR. By using the VR desktop users, this will attach in the questionnaire some websites that is leading to the experiment itself. So I will go to the result. The result will investigate first the effective performance of the architectural spaces. It can be done by defining these titles in subtitles, which is it will investigate the performance within the participant group, the differences within the participant groups. Also in a method of ranking the design type, and finally weighting of the design attributes. Second result, which is measure how likely this change of physical features of the architectural spaces will affect the effective appraisals. And this I used coloration analysis and also the interrelationship of the choices between the design attributes and effective qualities. Finally, investigating the effect of using virtual reality in versus the computer simulator walkthrough. So the first result of the result of assessing the performance of the design types, the result is showing that most of the participant is preferred high ceiling more than other physical properties, except architects with the age group 20 to 30 who prefer the traditional style more than other features. Um, Going to the ranking of the design type, the result is showing that all the group are preferred high ceiling modern style, while a low ceiling traditional style is not preferred in all group. And also going to the architect 20 to 30, they are preferring the high ceiling modern style, then low ceiling modern style, high ceiling traditional style, and low ceiling traditional style. And the range of the result, it's indicating that the range is highly wide in architects 20 to 45, which meaning that more participant is liking more the participants are from the architect 20 to 45 years.
However, we are in the last minute, so please, if you can summarize the presentation.
Okay. Weighting the design attributes, it's showing that the ceiling height is most important than finishing materials in all groups. The second one is assessing the variances of the effective appraisals. In this result, it's showing that I used the coloration analysis, and the finding, it's by using the SPSS statistic program, showing that the design attributes the assumption is the design attributes considered as an independent variable, and the effective quality is dependent variable. So the overall result is showing that the coloration analysis was weak, which is less than 0.03 in all the relationship. Therefore, the analysis of variances will conducted, and the result of using the assumption of sphericity, it's showing that if the result is greater than, if the significant is greater than 0.05, it will be a violated result. But the result is showing that the effect of the design attributes and effective qualities, it's less than 0.05. Therefore, greenhouse and greater correction will conducted. The result of this analysis is showing that both design attributes and effective qualities have a significant result, but there was a weak effect for the interaction between these set of variables. Finally, I will talk about the limitation of the study. The study was narrowed about to validate only 2 design types due to the limitation of the empirical study. And also the number of participants of using virtual reality was very low, which is due to COVID-19. The future research and recommendation, I recommend using more parameters and design attributes, such as lighting, opening windows, colors, and also using a variety of programs, professional programs and plugins. As well as does not limit yourself in indoor spaces. It's you can reflect the presentation for the outdoor spaces. It's also necessary to examine more physical attributes and effective qualities in this study.
Thank you. However, we need to finish right now.
Yeah, okay. Thank you for your listening, and you are a pleasure to ask any question.
Thank you indeed to all the presenters. now I have the honor to return the floor to Professor Habri to lead the question and answer session.
Yeah, thank you, Dr. Professor Samuel, and thanks to our presenters. We have so many questions, especially for the Dr. Sinha. The first question to Dr. Sinha, how do you validate the assumptions you put in your model?
Hi. We did not build a model. We just tried to derive a correlation between U value and RTV.
Okay. Also, how do you think homes need to be able to shift peak loads so they do not contribute to extreme peaks and grid failures? What sort of time lag should be built in them, if yes?
I'm sorry. Can you please repeat that?
Yes. What sort of the time lag should be built in the model or in the that you have built?
Um, uh, I think you're trying to ask about the thermal properties of the walling material. What might be the ideal time lag,
Yes. Is it 2 hours,
right?
for example, minimum?
So it would depend on the climate zone. So if you're talking about a hot and dry climate zone, we uh, generally we suggest that an 8 hour time lag is uh,
So there is a
like all
question
right.
from one of the audience saying, are there any lessons from the Indian vernacular architecture that can provide important design guidelines on materials or spatial arrangements for the new multi-million residential projects that you presented at the start of your presentation?
Answering it very shortly first, that we have learned many lessons from our vernacular building techniques and architecture, but none of them have been included in our codes. They are like thumb rules to us. So, for example, if you are building in a hot and dry climate zone, we would keep the windows as small as possible, ensuring ventilation, but not like heat coming into the a building. Versus if you are building in a warm and humid climate zone, we would have big windows and we would shade them as much as possible. So to also deal with humidity.
Yes, thank you. There's also a question about what's the influence of mass versus thermal transmittance in this approach. It is oriented to free running or AC buildings.
Uh, this code can be used to derive the thermal performance of an envelope. So it won't really matter to the code if you're taking a naturally ventilated or a mixed mode model. Sorry, building. It would solely depend on the window sizes, volume materials, etc. So does that answer the question?
So
Let me clarify,
yes, yes,
please,
please.
Dr. Harvey. It was a question from me because I noticed that all the code, all the approach is really strongly on the transfer in U value. So that is related to a steady head flux. But when you have free running buildings and when you have to suffer daily oscillation from temperature, the mass may play a very important role in the energy balance. So how's your estimation, your guess about this issue?
Okay, so how the thermal mass of a building material would play into the thermal performance of a whole envelope. Is that right? Am I getting it right?
Yeah, yeah. Mhm.
So when a material has a lower U value, which means it would let less heat transmit into the building.
Okay. Also, what is the actual performance on comfort and indoor control for each climate? Do you have an estimation for that?
I'm sorry, I'm losing my network. I apologize. Can you repeat that?
Okay, what is the actual performance on comfort and indoor control for each climate? Do you have an estimation?
Mm. So we did not derive any specific performance parameters. It is just the code that we were adhering to, the ENS. It prescribed us values of 15 watt per meter square RETV, and we had to just comply to it. So yeah, we did not
Also,
try to derive. Yeah.
okay. Also, how are the solar horizon and sun obstruction considered in your model? How do you consider solar horizon and sun obstruction?
I'm sorry, I don't understand. I'll read up about it and get back to you.
Okay, thank you, Dr. Sinha. Now the next questions to Dana. There is a question that your study does not mention two key issues for a sustainable house.
Yes, I want to make it clear that the study paved the way for creating a sustainable rating system. What is mentioned in the presentation, what was explained from the stakeholders that as an element for sustainability. So what is shown here, it is only the term that have the highest silence index, not not as indicators or categories.
So, I couldn't understand your answer. So the question is, you didn't mention two key issues
Yes,
for a sustainable house.
yes. I want to make it clear that the approach in this study is it is not from the top to the bottom. It is based on going down to the society and the stakeholder and understanding what makes a building sustainable for them. And starting from this point, so we can analyze what make a building sustainable for the stakeholder. Yes, correct. This study doesn't shows the keys of sustainability, but it paved the way for the future creation of a local rating system based on the need of the stakeholders.
Okay. Also, what is the number of participants in the pile sorting?
The total number of the participants in the research was 116, but in the pie sorting, we have a total of 7 that present each group, which are the government sector, educational, and developer. And only we didn't find an access for the local contractors and the user of rated buildings in Oman. So only 7 for the pile sorting.
Okay. And also, what is the high interest and high power groups response to implement green areas?
The highest power and the highest interest was the player and BDO and Muscat municipality and the Superior Council, they are the most interested in this area.
Okay, thank you, Dana. Now the next question is to Jawahar. What was the top learning lesson for you for your for you from your study? What was the top learning lesson for you from your study?
Hello, Professor Khalifa. Did you hear me?
Sorry?
Did you hear me? Yes, you mean that what is the aim of my study?
No, it's the question said, what is the top learning lesson
Okay.
from your study? You learn from your study.
Yes, the study will focus on the relationship of the effective appraisals and physical features of the architectural spaces. So some users it feel it's difficult to judge the architectural spaces. So I developed a framework that could help the users to make it easy for the users to judge about the space. Either it is existing, exciting, or pleasant, or relaxing about the space. So this will help about the designing the architectural spaces will be very effective way يعني, of designing architectural spaces. And also it could be related to the sustainable building by using this framework to develop or adding more design attributes that يعني could help the space to design it in a limited time and a limited cost. This will lose cost and time of designing static. It's rather than static drawings. So this could help to design more sustainable architectural spaces in the future.
Thank you, Jawahar. Also, there is a question. You mentioned that high ceiling height is preferred for many. Should the ceiling height be less to save building costs and increase energy efficiency?
Yeah, I agree with Haytham Ar-Rashdi, but designing high ceiling is the designing of high ceiling is preferred for many. On the other hand, there are many parameters that could help to save energy by adding some passive strategies that could help a lot in the design itself. And also because some spaces it is a must to design a high ceiling according to the space area in the ground. So you cannot make like the height is very low in a large spaces. It's depend on the user's needs.
Okay, thank you. Also, there's a comment from Dr. Suraouf regarding, yes, I totally agree with you. This is, I think, for Dr. Samuel, but I can comment on your point. You are correct that Oman now is facing cyclones, flash floods, extreme heat. And actually, we need to consider this when we talk about the green rating system. But I think Dana in her study, she concentrated on buildings. There's different kinds of rating systems. Some rating systems are for community and others for projects as a whole. But I think Dana is concentrating on the rating system for buildings only. I totally agree with you. I gave presentation 3 years back, and I mentioned these disasters or these points in my presentations that we need sustainability. We need sustainable strategy, and also we need green rating systems for our urban planning strategies, and also for the natural disasters, because Oman is facing different natural disasters, as I said, flooding, cyclones, Also, tsunamis could be a problem. Also, if an earthquake happened in the Arabian Sea or even in the ocean. So I totally agree with you. We need to address these issues crucially in the future. Thank you so much. Uh, there is the last question also from Dr. Sood saying to Jawahar, what was the top thing they wanted? I don't know.
What do you
They,
mean by
what do you
top
mean?
10?
What was the meaning of they? Yes, go ahead, Jawahar.
Yeah, I don't know what is the meaning of that question.
Okay, any further questions? Prof. Samuel, do you have any questions?
Yes, but I think I want to give the floor for a while to Professor Surrov to clarify this question, but I think it's a very critical point. Susan, do you have, can you speak now? I'm trying to give the floor to the Professor Surrov.
Yeah, okay, I can unmute. Yeah, can you hear me?
Yeah, we can
Yes.
hear
You can
you.
hear you. Okay, listen.
Thank you very much for your intervention, for your questions.
Okay, no, as always. But there seems to be all this concentration on adopted methodologies, which are brought in from different countries and different places. And there's not that much evidence of what it actually means. So I'm seeing lots of methods and correlations and this, that, and the other. I'm not getting much meaning. So it's basically the bottom line is, so this affects me how? So what? What has your study actually shown or proven? Now, in Jawahar's, I mean, it's a very important point. People want high ceilings because people aren't stupid. And if you have a low ceiling in a hot climate, it's bringing radiant heat closer towards you. So that's perfectly understandable, while the developers want low ceilings so they can make more money. But it's just that again and again, I have this concern in a lot of research projects I review and papers I review, that people are just blindly adopting sustainability indices and stuff like that, which were developed in different countries by different people for different reasons. And I just think that things are changing so fast that one really has to adapt and think very deeply about what matters for that particular climate. And I've sent Dana a number of my books and related papers. We did a lot of work in Scotland on indicators for resilience over 5 years, so we could actually measure what was happening. So I hope they're useful, Dana, but I just wanted to make that point, that rather than just repeating methodologies which are very impressive, but what is fundamentally important now is that one understands what they mean and what they mean for a particular place. So sorry to go on about that, but I just thought it was worth raising.
Yeah, thank you, Prof. Susan. I received your email and it was useful to know about your book. So thank you very much.
Yes, thank you, Dr. Susan, for your comment. And now we will come to the end of our session. And I would like Professor Samuel to conclude this session.
So, what's a very interesting and arises a lot of questions and issues that we have to deal with. And I want to take advantage of my position to make a final question for every panelist. But I need a very short answer from you. And from the point of view, what a real code or a real sustainability code do you think must to address? Please, in one sentence. Hina? Sneha, sorry.
Can you repeat that?
in one sentence, what a real sustainability code do you think must to address, what must to drive? What is the key point for you for a real code, for a real life code? In a short answer.
It's reduce basically whatever consumption, any kind of consumption, reduce. That I think that is sustainability to me.
I see your point of view. That you have to limit, you have to reduce energy because it's a very systemic risk for a big country like you. So thank you very much. Dr. Dana?
For me, I think the cost should be one of the categories and indicator, especially here in Oman.
Thank you very much. It is very important, the affordability of the code, the viability for a real life. If we cannot achieve the goals, we will be for nothing useful. So thank you very much. And Hawa?
Excuse me, my name is Jawahar.
Sorry very much.
No, it's okay. Sustainable. It's we have to consider some sustainable factors, but on the other hand, we have to meet the need of the society in very effective way. So we have to balance between the sustainable issues and the sustainable needs and also the society needs. So we need to consider sustainable and more effective to make the users or the need of the users very effective in the society of the industry.
So thank you very much. I apologize for made a mistake in the name. But with these three ideas, we can summarize that for a real life codification standards, we need to manage to reduce the use of external energy, to keep costs as low as possible, to be able to spread the solutions for everybody, not only at a personal level, but also at a social and country level, and to balance to achieve needs for everybody. In most of cases, we have seen underperformance buildings and housing, and everybody has some kind of desires, wishes that have to be resolved. So in the future, I hope with the effort of all of us working together, we will be able to evolve to real codes that allow us to go a step forward in this pathway. Thank you very much for all of you for the attendance. It was a very interesting and happy discussion. So I return the floor to Professor Al-Jabri for closing the session.
Yeah, at the end of this session, I would like to thank our presenters for their impressive presentations and for the informative presentation as well. And also, I would like to thank our audience, and I hope they did not face any technical issues to attend these sessions. And I hope to see you in other conferences in the future. And I would like to thank Professor Samuel for helping me to run this session successfully. Thank you so much, and I wish you all the best. And have a very good afternoon and very good evening. Thank you so much.